Good afternoon, everyone. Welcome to today's webinar on metal forming simulation. My name is Corinne Bossy. I work in the marketing team at Altair UK, and I will be your host for today's webinar. We've got two presenters on the line for you today, Rob Shropshire and Tim Dukes from Origin. Origin is a partner company of Altair, and they specialize in simulation for the manufacturing industry. And in today's webinar, they will introduce you to the Altair Inspire Form solution. So just a couple of housekeeping items very quickly. Your microphones are muted by default, but you can use the questions box in the webinar panel to ask questions at any time during the session. And Rob and Tim will be online and stay at the end to answer any of your questions towards the end of the session. We should take approximately 1 hour today. This session will be recorded, so you'll be able to watch the recording afterwards if you need to look at it again. Okay, I will just turn you over to Rob to get started.
Thanks very much for Corinne, and thanks everyone for joining the webinar today. Thanks to the Confederation of British Metal Forming as well for helping us promote the event and doing it in conjunction with them. So I'm Rob Shropshire. I lead the sales and marketing side of Origin. Won't be doing a lot of the talking today, apart from a short introduction, but I will be your contact if you want to chat to us further moving forward. Really pleased to be joined by Tim Dukes, who is a co-director of Origin and is our subject matter expert, having been working in the manufacturing space for the last 10 years or so. He also looks after training and support for a lot of our customers. So as I said, keep the introduction fairly short, but I think it's important to set some context in terms of why we exist and what we think the benefits are to introducing simulation to your business, or perhaps rolling it out to more people within your business. I'll then pass on to Tim, who will discuss what Altair Inspire Form is and what types of challenges it helps companies solve. He'll then provide a high-level demonstration of how the solution works. Now, after the event, we will be providing a trial and also offering some support if anyone does want to test it out and see how it might benefit their business. As Corinne said, we prefer the sessions interactive, so do ask questions, and we'll leave some time at the end to make sure we get through them. So Origin have around 200 customers, all of whom are in the manufacturing space. I think what's unique really is our focus on the design side, and also working with manufacturing engineers. So we're really trying to advocate for simulation much earlier in that design process, where a lot of the sort of man hours and design time is spent. Simulation tools are used by some organizations. Perhaps sometimes simulation is outsourced, but we find when it is in place, it's typically used perhaps when something goes wrong or right before production. So our belief is by doing it much earlier, businesses can save money and time and hopefully allow it to become a little bit more competitive. We've partnered with Altair because we feel the solution is great, of course. It provides the functionality that you need, but it also provides it at a fraction of the cost compared to a lot of the solutions out there. I think what's also unique about Altair is how easy the software is to use. I'll let you be the judge of that when you look at Tim demonstrating the product, but typically it only takes a day to get going, so a very low learning curve. So as I said, we believe simulation should be done much earlier. The most obvious benefit is to allow companies to spot typical defects associated with the forming operation much earlier, and Tim will cover what some of those are a bit later on and show you how we identify them. As well as eliminating defects, we can allow designers to actually explore more concepts a lot quicker. So we really give them the chance to iterate that design and give them a chance to optimize the design to produce higher quality products. Without simulation, then, businesses do often have to rely on trial and error, perhaps validating a design through some soft tooling, or perhaps doing a sort of smaller test production run, which typically takes a lot more time. So we hope by running simulation and answering those questions quicker, we can help you get a product out much quicker. From a work winning perspective, simulation users can differentiate themselves against businesses that aren't using simulation by allowing them to provide evidence of their ability to be able to make that product free of defects. So just one slide just to show some research that the engineering.com conducted, where we can see they reached out to manufacturing organizations to learn more about what benefits they expected before buying simulation and what they actually got. So on the left hand side, you can see that the main reasons bought the simulation product was really to try and reduce part and tooling costs, to speed up production and increase quality through the reduction of those defects. On the right hand side, then you can see what businesses actually got, so what they realized after implementing the product, and you can see that over half are reporting a reduction in cost and 48% are enjoying a higher yield. So you know, we're not making these benefits up, that they are proven. So this might be something useful if you're trying to get your business to invest for the first time. So if we just sort of take a look at the industry at the moment and perhaps moving forward before I pass over to Tim, we are seeing that businesses often rely on the skills and know-how of their staff to deliver quality products, which is the right thing to do. The problem is that those skills, as the workforce gets older, those skills are leaving the business. So I'm sure every attempt is made to transfer knowledge, but you can't transfer 30 or 40 years worth of knowledge to someone that's just starting their career in the forming sector. So it's about future-proofing. And if we look at graduates, most of them will have been taught simulation. So they're actually very used to using this technology to validate their decision-making and their designs. And we'd also suggest it's something that they're just comfortable with doing. So reduce defects, increase quality, but also what is the succession plan of your business and what happens when those skills leave the business? Now, obviously, I won't state the obvious too much, but we're seeing costs increasing. We're seeing overseas companies offering services at cheaper prices, often undercutting UK businesses. So how can we make sure that we're increasing our productivity and reducing our costs to stay competitive? We're also seeing increased complexity to the parts that need to be produced. And because the part complexity is increasing, so is the tooling design. So having those simulation tools to deal with those challenges is certainly very useful. Customers also just expect more. So they expect lead times to be lower and they expect delivery timeframes to be faster. So everything that we can do to accelerate production and get products out the door quicker is surely a good thing. So I think that's enough from me. You know, I think to close that, hopefully at the end of the session, you'll be convinced that simulation is worth considering in your business, or having that internal discussion. You know, answering the questions in terms of what does the future look like? You know, are we managing to bridge the skills gap and the people leaving the business? Are we doing enough to try and streamline your production process and perhaps be competitive? And if you're running simulation already, then at what cost? Is there a more cost-effective option for you to explore? Or if you've got a simulation tool in place that you're happy with, a lot of customers find it hard to give those simulation tools to the people that need them because they are too expensive. So could you perhaps also introduce Altair, perhaps alongside an existing product, to increase the amount of people that have access to simulation?
So thanks for the introduction, Rob. 2 seconds, just going to get set up. Yeah, so thanks for the introduction. My name's Tim Dukes and I'll be taking you through the Inspire Form solution. Before we jump straight into the demo, we're just going to go briefly over like what is forming, you know, what is Inspire Form itself, and why use forming simulation or simulation in general. Inspire Form sits on a platform of Altair products. This is called the Inspire platform. Just to quickly go over this platform, there's a number of products within this range, this platform. Starting on the left hand side, we've got Inspire Studio. This is like a design / rendering product. We've got a structural / motion physics and optimization tool called Inspire. We've got Fluid tool. We've got an Inspire Cast tool for casting simulation, injection molding, extrusion, which is metal and plastic, and then we've also got Inspire Print 3D, which is for metal 3D printing. So if you are interested in any of those tools, feel free to get in touch. but obviously today our focus is going to be on the Inspire Form software. So most of you will be probably familiar with what is forming, but just to quickly give you a bit of a background, like obviously metal forming or stamping, also can be called pressing, is where sheet metal, which is known as a blank, is fed or placed into a press. The press then forces this blank into a die or tool to create the desired shape. So depending on the complexity of the part, there might be different operations after the initial draw or pressing operation to get the final part. The blank obviously can vary in thickness. We can have different size blanks, but we can also use tailor welded blanks where the blank actually varies in size. Inspire Form can simulate cold forming. Hot forming, where the blank is actually preheated, we don't do within Inspire Form, but Altair do have a number of products. So if you are involved in hot forming, please feel free to drop us an email, a message, and we can show you what we can do later on. But today we're going to be focused on cold forming. So here on the left hand side, we can sort of see the progression of a form part, where we start with a blank, and numerous operations down the line we get into the final part. But obviously there's different types of forming that we can do, but that just gives you an idea of from blank to part. So how does forming work? So we've briefly touched on this on the first slide, but there's a number of different forming processes. The image on the right hand side is actually a deep drawing operation. So there's different operations that we can simulate. But in the operation for this one, the sheet metal is held against the die by a binder or blank holder. If you're doing crash forming, this might not be the case, but the blank holder applies a predefined force to basically control the flow of that material. If all goes to plan, once the part has been formed, there'll be relatively small changes in material thickness. Obviously, if there are large changes in material thickness, that might be where we start to see defects such as splits, wrinkles, compression, all those sort of things. So obviously what we're trying to do is have as little change in thickness as possible. Just a few other different sheet metal forming processes. So you can see on the left hand side we've got single action, on the right hand side we've got double action. We'd probably say single action is probably the most common type that we see, but there are other types that we can simulate as well. Obviously in double action, the top die will include the blank holder and the top die. The blank holder will basically come down and clamp the sheet against that bottom die. The top die basically moves and forms the sheet against the bottom die. Obviously, once this is done, the top die retracts, followed by the blank holder, and then the part is ready for transfer. So there's different types of forming processes. These are just a couple. We can simulate gravity, crash forming, single action, double action, numerous different types that we can simulate. These are just a couple of them. Different parts that we can simulate. So I think form parts, I think one of the main things that people come to mind is automotive parts. A lot of automotive parts are formed or stamped, but numerous different parts can be manufactured using the forming process. So these are just a few little images of different parts that are created using this process. I won't spend too much time on there. So now we'll just briefly explain sort of what is Inspire Form. So Inspire Form is basically a simulation tool that allows you to simulate the entire forming process. We like to think it's got fast onboarding and a compelling licensing model. So what we mean by fast onboarding is we like to think it's fairly easy to use, easy to learn. So generally, as Rob mentioned, we give a day max. Sometimes customers take half a day, and after a day of training, they're up and running and comfortable using that software on their own to get results. The licensing model won't go too much into. I'll explain it when we look at the demo, but it's basically a floating license, but it is a unique sort of a cloud-based floating license. The license is held, the software is local though, and it's got a user-friendly workflow. You'll see this hopefully in the demo, but the workflow's we like to think quite easy. It's a standard sort of left to right workflow, and hopefully you'll see how simple that is, which again allows any engineer, regardless of skill level, the ability to hopefully use this software. How does it work? So many of you will know how simulation works, but just in case anyone doesn't, the software basically turns a CAD model, a 3D model, into a mesh. You can probably see the image on the right, sort of these little squares, which are called mesh elements. And a very simplified version is that we run calculations on each of these elements, which allow us to get the results. The software has auto meshing, so you basically define your mesh size in the software, but you don't have to be a mesh expert to be able to use it. So it's easy to use, and you'll see this again when we actually look at the software shortly. So this is the workflow. So in the demo, we're going to be looking at two methods, two demos or two workflows within Inspire Form. This is the workflow for what we call feasibility analysis. This is actually what we call like an inverse method. We actually start with the 3D part and then end up with almost a flat blank. So this is great for like quick and reliable checks, just very quick checks of the actual formability of the part early on in the product design stage. Especially if you're subcontracted and you're bidding for work and you get sent a 3D part and you just want to quickly check if that part is feasible, it is formable, and potentially where are the errors, you might see the errors. In this stage, we can predict things like splits, wrinkles, loose metal. So this is going to be one of the demos we look at, and we can also do nesting and stuff, and nesting as well, to optimize the material layouts. So that's going to be one of the demos we look at, and the next demo is basically where we start with the blank. So we start with a flat blank, and then we form the part, and this allows us to do multiple operations. So if you have got multiple operations, for example, a trimming operation, a flanging operation, we can simulate all these operations within the tryout analysis. So this is a little bit more in-depth analysis. It takes a little bit longer to actually simulate, but this is a more realistic process of your actual, potentially your forming manufacturing process. So why use Inspire Form? Rob's briefly touched on this. So these are obviously one of the main reasons to use simulation in general is to sort of hopefully predict defects before manufacture. The last thing you want to do is go and manufacture or expensive dies or tool, and then you're forming your parts and you find that you're getting big errors such as splits and things like that, so the parts are no good. Obviously, dies and tools can be fairly costly, so the last thing you want to be doing is going through trial and errors in that process. So if you can do all this in the virtual stage and get it right there, and hopefully this will increase your manufacturing speed and reduce those costly trial and error stages. Obviously, another point that Rob touched on, so I'm just going to show you a few of the obviously defects that you find within forming, but another point that Rob touched on is obviously when bidding for work, if you can prove through simulation that you are able to actually manufacture that part error-free, does that give you an advantage over your competitors, and does it allow you to have USPs and potentially win more work? So there's a lot more errors that we can look for, like surface defects and things, but some of these are the main ones: splits, wrinkling, springback. Some of these are the main errors that we look for when we're forming. So the outcomes of using Inspire Form. So the main outcome is to basically study all the stages of the forming process, and hopefully by doing this, we're able to identify defects and iterate the process parameters to improve our part design. So we're going to go on to the demo in a second, but these are hopefully the questions that Inspire Form can answer. So can I form this part? What is the best, if you're investigating different materials, which is the best material to use? You predict the flat pattern, optimal layout of that flat blank. Will the part have defects? What are they? Where are they? And potentially then can I modify the parameters to actually hopefully remove some of these defects? So these are some of the questions that hopefully Inspire Form can answer. So now we're going to go on to a live demo. I'm going to just hopefully share my screen in a second. And I'm just going to just turn off the webcam so you can hopefully see a bit bigger and it doesn't affect any bandwidth. So hopefully you're now seeing my Inspire Form screen.
Yeah, we can see that, Tim.
Brilliant, thanks, Rob. First of all, before I jump straight into the live demo, I'll just go over the user interface just so you're familiar with that. The user interface we like to think is quite clean, quite easy to navigate. So again, that lends itself to being easy to use and easy to learn. But like many other softwares out there, you've got tabs along the top. So hopefully you can see all these tabs along the top. At the moment, I'm in this tryout stage. In the tryout stage, we'll be going through a demo with this shortly, but the workflow is always left to right. So you start from the left, add your operations, so you can hopefully see all the different operations that we can simulate there, and then get your results. Same thing in the feasibility tab, left to right workflow, and we'll be looking at that first. But other tabs that we've got in Inspire Form, we've got the geometry tab. This tab basically allows us to create and modify geometry. So, you know, if you need to modify the size of rads because you're getting errors in your forming part, you can do some geometry modification in Inspire. It's not a fully fledged CAD tool, so but it has got quite a fair bit of CAD functionality within it. So I'll show you a few of these tools when we go do a demo, but they're there. Then we've got obviously a 2D sketch tab, so hopefully you'll be all familiar with 2D sketch tools, so we can create geometry from scratch using the 2D sketch tools. You've got your view tab next, so you'll notice that I've got my model browser and property editor turned on, and this is basically just what you like to view. So I like to have my model browser on, and basically this will be show me whatever I import into the software will be here, the assemblies, and anything I create will appear in here. And same with my my property editor window, I like to have that on as well. Edit, just your Microsoft shortcuts, undo, redo, copy and paste, everyone will probably be familiar with those. And then file, pretty much standard in most softwares, on the left hand side, opening and saving files, pretty basic. But from here you can also do screen captures, you can do little videos, you can take snapshots, you can direct links to help files or tutorials, and also the licensing. So as I mentioned in one of the slides, the licensing, it's a floating license, but it's a cloud-based floating license, so it lends itself very well. It's a great licensing model because traditionally a floating license, the license would be on the server. This license, whoever opens a software grabs the license, and what that means is if you're working from home, if you're working away from the office, you can still grab that license. You don't have to be connected to the server. If you are going onto maybe a customer site and you know that you're going to be without internet access, you can take this license into an offline mode. So you basically take the license locally onto your machine for a set period of time, or until you log it back in. So licensing is quite a nice licensing model. Down the left hand side, we've just got our views. So these allows us to create section cuts, snap to different sorts of views, work in perspective, orthographic, and then on the that's the left hand side, yep. And then on the right hand side, we've got our units. So you can work in different units, you can set these to however you want, and you can also customize them. So if you like to work in millimeters but you want to work in pounds of force, you've got that option as well, so that can all be customized to your user preferences. So we're going to jump into a demo now, so hopefully you get an idea of how the software works. First of all, let's open a file. And these are all the different file types that we can open. So hopefully you can see numerous different CAD types, so it doesn't matter potentially what your supplier is using. We can generally open it in Inspire Form. If you're working with automotive parts, it might be CATIA, but you can see we can open up Steps, IGES, SolidWorks, Parasolids, Inventor, you name it, we can probably open it. So I'm going to open up a Parasolid file, and this should import the solid into Inspire. So this is the imported part. So this is a solid model. I can tell this by just initially looking into my tree on the left hand side, and I can see it's like a solid cube. If I zoom in, obviously it's got a thickness to it, so we can see I've got a thickness to this. I can just quickly take a measurement if I want to actually just quickly know what that thickness is. So I can see here the material thickness is 1 mil. So let's just zoom back out. So I'm going to be doing a feasibility analysis, a quick analysis that allows me just to see basically the formability of this part. So I'm going to go into the feasibility tab, and the first thing we need to do is extract a face. Generally, we like to use the mid surface, but if your part it has got changing in thicknesses, it's maybe not got a total uniform thickness, sometimes it can be difficult to extract that mid surface. So you can use an outside face as well, or a top face or a bottom face. So I'm going to use the mid surface. I basically click on the part, and this will just convert this into a surface. So this is obviously the material thickness. So obviously it knows that it's 1 mil, and then we can choose the mid surface. I'm just going to hit the tick box just to accept that. And this will change this from a solid into a surface. Okay, so now I'm working with a surface, and we can see again the symbol's slightly changed in the tree on the left hand side, so we've now got like a surface symbol. So we always work left to right, so the next step is to potentially defeature it if need be. So we can click on the defeatures tool, and we've got a number of tools within here that allow us to defeature the model. The first one is the hole tool, so this sort of keyhole here I'm going to remove, because that might be a separate operation afterwards, but I'm going to remove it. So I'm going to click on there, and that should remove that hole. So we can see that's just removed. I'm then going to use the cutout tool just to also defeature a few of these like sort of cutouts here. So to do that, you basically just click 2 points, you get a bit of a preview of where it's going to fill, and then you can just fill these cutouts by doing this. So very easy to use. The second thing I'm going to do is I'm actually going to fill in these radiuses on these corners, and you'll see why in a second, but you can use that cutout tool to fill in these radiuses. So you can see I'm just bringing them back to a straight edge. So we've just defeatured our model. We're ready to move on to the next step now. Before we move on to materials, I'm going to show you a few geometry tools. So I'm not going to be able to show you them all, but I'm going to use the mirror tool. If it is, you've got symmetry, a part with symmetry, you don't need to physically mirror the part. You can actually set symmetry planes, which is going to speed up your analysis. But I'm going to mirror this part, and I'm actually going to offset it by a fraction just using this move tool. So you can see here I can type in a value. So I can create a mirror out of this part, and I'm going to hit the tick box. And then I'm going to use my Boolean tool just to combine these two together. So I'm going to recognize them as sort of one surface. So you can see in my tree I've got one surface now. And then I'm going to actually use my patch tool to create a patch between them. So this is just showing off some of the geometry tools, literally just and I'm going to just click on these edges. I can create a patch or a blend between these surfaces. So I'm going to accept that. You've got different options matching the tangency of the surrounding surfaces, or just a straight blend. I'm happy with that, so I'm going to hit that button, and we can see the surface that I've now created. So that's just showing off a few of the geometry tools. Again, you can change the size of fillets, extend stuff, that sort of thing you can do with these geometry tools. But the main thing is obviously the feasibility and the tryout analysis. So next thing to do is obviously specify a material. So if I click on this material icon here, it brings up our library of materials. So at the moment we're looking at steels. We can then look at the different grades and standards of steels. I'm not going to go through them too slowly, but you can hopefully see a number of different grades and standards, and some that you might recognize. So those are your steels, and then we also have a number of aluminiums. If you do have your own custom materials, or you've built up a library over time, you can obviously input the properties into Inspire Form and use your own materials and build up your own material library. Altair also has links to its own data center of materials, so there might be more materials in there. But on the right hand side, hopefully you can see the properties that make up the material science. So we've obviously got our elastic properties for each material. So if I just click on T6, we can see the elastic properties for T6. Then we've got the plastic properties, and then here you can see our stress strain curve and all the properties that obviously make up that material. So if I go back to steel, let's choose a material to use. I'm going to use 210B, and I'm going to hit create, and I'm going to just say update. To make sure this is actually using that material, I'm going to right click on it, go to material, and just make sure it's ticked here, so that I want to make sure I'm using that material. If you did import, like for example, a surface into Inspire Form, and you wanted to specify the actual thickness, you can just use the thickness here. And obviously this is 1 mil, but if I want to change that to 1.2 or again investigate different thickness of the parts, you can easily do that just by changing the thickness here. So that's your materials. The next step, again, when working from left to right, is to basically choose a stamping direction. So first of all, the software sort of looks at the part and it tries to give you the best stamping direction to remove negative draft angle. But sometimes that might not be what the direction you want. In this instance, I don't want the software to do that. I want to specify my stamping direction myself, which might be aligned with an axis potentially. But if I choose the Z-axis, you'll see this sort of like color map appear on the part. So this is showing us that negative draft angle. So we can see that the yellow areas, we've got a draft angle of 0 to 10 degrees. The red areas, we've got a draft angle, the maximum draft angle in this instance is 74.6, but between 10 and 74.6. So it will show you that if you've got negative draft angle in your stamping direction. I'm going to specify the Y-axis because that's the axis I want it to be, and I'm going to accept that. The next mode is to actually constrain the model. So we can constrain it. We can add pins, we can add blank binders or blank holders, or we can add draw beads. I'm not going to do this for this first simulation. I'm actually going to just specify this as going to just be a crash form part. So then hopefully we can compare results between one that's been a draw action, that's obviously being constrained, between a part that's been crash formed. So once we've done that or haven't done that, we can go into the next stage, which is basically run analysis. And this is really where we're specifying our mesh size and the analysis that we wish to run. So we can rename our run here. Obviously we're doing a crash form and this is our mesh size. So I'm specifying medium, but you can also choose coarse or fine, or you can actually choose your own mesh size. So we can do a custom non-uniform or custom uniform mesh, and you can obviously specify your mesh size. Obviously the finer the mesh, the longer the simulation will take to run. But so there is always that trade-off between accuracy and speed. Then you've got your friction coefficient, and if we do want to simulate springback, we can do as well. I'm not going to do this for this first run just to show you how quickly we can get results, but I'm going to click run, keep it on medium, and generally we should have results in probably about 10 to 15 seconds. So you can see your sort of status bar. It's doing just one operation, obviously crash form, but within like sort of 10 seconds we hopefully will have actually some results that we can start to analyze. So I'm going to let this simulate just so you can see the speed. It's always a little bit quicker when I'm not presenting live as well, but we've got results. So I can load those results in straight away, and let's just let them load. Okay, so we've got our results loaded in. Let me just bring my Analysis Explorer a little bit to the left-hand side. First of all, we'll just show the animation of this part being formed. This is your animation settings. I always like to take it a lot slower, so I'm just going to take that slower so you can clearly see what's happening. But these are just your animation settings, and these can all be customized to suit. And then I'm going to hit the play button. So now you can see our part being formed. So I'm going to just pause the animation, and that's in its sort of final state. If we look at the Analysis Explorer on the right hand side, at the moment we're looking at thinning, so we can start to see the areas that are thinning and the areas that are potentially thickening. So we can see that change in material thickness. We can put callouts in any of these areas, so we can put callouts in any areas that you're interested in. And if you put callouts, these can also be seen in your reports. But other things we can look for at this feasibility stage is thickness. So obviously thickness and thinning will be similar, but this time we're actually getting a thickness result. So let me just put a call out here. So you can see my call out up here. Let's put another one down here. So you can start to see obviously the change in thickness when your part is being formed. Other things you can look for in this stage is your stress and strain. So we can start to look at the equivalent stress and strain on the part, the major stress and major strain, press tonnage and displacement. But one thing you might be interested in is the formability of this part. So I'm just going to So I'm looking now at the formability. I'll make that a little bit bigger so hopefully people can see it. Zoom in a little bit. So this is the formability of the part. If you look at the analysis explorer on the right hand side, we can see areas that are going to fail. We can see areas that are marginal, which in this case it's not going to fail. But so a lot of it's in the green, but we are getting quite a lot of compression. We are getting quite a lot of loose material, and we are getting a few wrinkles as well. So we can see where these are on the part. So we aren't going to get any splits in this instance. We're not going to get any tears, but we are getting a little bit of loose material. So we can start to see that, and obviously the aim is to get as much as much as possible in that green area to get the best parts. So at this stage, we might be investigating materials, we might be investigating different constraints. We could quickly, and hopefully you can see the speed of this. We could quickly investigate like 2-3 materials within a second and say, okay, well clearly the X material is going to be the best material to use for the formability of this part. So that's something obviously we can do in this feasibility stage. If I wanted to, I could constrain the part. So if I just now come out of the results, I can add constraints. So let's say, for example, I'm going to add a blank holder in this part, and I'm going to just choose 2 surfaces as my blank holder and say create. And then we get to specify the force of these. So in each of these, I can specify, you can choose your own force, but we can choose these high, medium, or low. I'm going to choose low. And then we can accept those. So now we're actually going to run this with a blank holder. And I can also run it with springback as well. So we could also run this rather than run this and let it simulate. This probably will take about 1 minute to 2 minutes. Obviously, for the purpose of time, we are limited to time here. So I'm going to just open up the results so you can and I'll show you. Hopefully, you can compare the two. So let's just open up a completed run. So this has got both of the simulations in, both the same material, but in one we've constrained it with a blank holder. One we've done a crash form, one we've done a draw almost. So if I just show the first one first, and let's just go to that formability again. Let's make this a bit bigger. So this was the first one, the one that we basically just looked at. So we can start to see those areas again. You can see a lot of the blue, green. So if we jump to the second one, this is the one where it has been blank holded. So we can see a lot more of this in that green area. So hopefully we can see a lot more. Again, there is still a little bit in the compression, the wrinkle areas, but a lot less. So so again, might not be perfect, but this again we can quickly see by using that blank holder, we're getting a better form part. Other things that we can do with this analysis explorer is, one, we can actually physically show the mesh. So I've just turned on the mesh using this little cube here. So that's sometimes useful to actually see the quality of your mesh. You can just turn that on and you can see. So obviously I've got a non-uniform mesh here, but you can use a uniform mesh as well. So I like to turn that on just to have a little look and then generally turn it off. Other things that we can do is, obviously we've seen we can add callouts, we can compare results between numerous runs. So if you are investigating different materials, you can compare results. You can turn the part on and off, so you can see you're not seeing the outline of the previous part. We can snap to different states. So we're on the flat there, and then we're on the form. You can turn off your color map, so you can see that's the flat, and we can actually show the thickened part as well. So if you want to actually use this blank, you can also use this blank. Whenever you run a run, you'll have the blank in a folder. The blank will appear in your run folder, so you'll have a DXF and an IGES file of your actual blank part, so you can actually use that if you wish. Reports, I'll just open up a report and just show you the sort of thing that we'll see in the report stage. I will just have to change my screen, I think. So let me just change my screen. There we go. There we go. So you might be seeing my report screen now. So this is the sort of thing that you can generate with your report generation within the feasibility. Same thing will appear in the tryout stage. So this is just a PowerPoint, so it'll automatically generate a PowerPoint report. The template can be customized. It's just a PowerPoint template that you can customize yourself. But these are the sort of things we can see. So we can get a nice visual report from the software. And obviously it's a PowerPoint, so you can customize it as well yourself. So I won't spend too much time on that, but let's just jump back to the application. Okay. When generating a report, you basically choose what you wish to include in it. So you can include any results that you wish. That was a different model, but just give you an idea of the reports. Another thing you can do in this stage is you can you can do the blank fit. So if we run a blank fit, it obviously allows us to do material utilization. So we can obviously fit this part to just different shapes. These are all your costings. Again, you can customize all that, but you can choose to do different shapes. And once you've done that, you can run a simulation. I've already run one. Again, I'm going to just change my screen so you can see this, because this basically creates a HTML. So you're hopefully seeing my screen again. And then you can start to see your material utilization of each shape. So we're looking at rectangle here, 56.64. Obviously the optimal one is technically a chevron. There's only a percentage point in them. And then you can click on here and actually get the report. And it's exactly the same thing for the blank nesting as well. So you can start to see that material utilization. So obviously if the rectangle was 10% better than the chevron, you're going to use the rectangle to reduce some material wastage. So that's what we can do with nesting. Again, I'm not going to spend loads of time on that, but it's hopefully fairly explanatory. So what I've just gone through is the feasibility analysis. What we're going to look at now is a multi-stage tryout. So we're going to go into the tryout tab, but hopefully you get an idea of what you can do with that feasibility stage. So with all these tools. So now we're going to go into the tryout stage. And first, let's open up a different part. Let's open up this part. So in the tryout stage, we actually start with your tools or your die and your blank. So you're starting with a blank and then hopefully forming your part from that blank. So again, the workflow is left to right. So in this instance, first I've got to specify my blank, which is obviously this part. And if you're using tailor welded blanks, again, you can specify those as well. So I'm just using a single blank, clicking assign. And then we can choose our materials. So exactly the same material database as before, so I'm not going to go into that, but here we can choose different materials. I'm going to keep it as 1 mil thick and the default material, but hopefully you saw the material database earlier. So I'm going to accept that. This is the rolling direction. So this is the rolling direction. It's come off potentially a coil if it has done, so you can also always specify that as well. And if you want to change that, you just double click and you can change it to any axis or just manually move it around. So we don't need to add any constraints in this instance. We can add symmetry planes again if the part is symmetrical. Again, we won't look at materials, but now we can add our operations. So these are the operations that we can obviously simulate: gravity, crash form, single action, double action, flange, trim, springback, and we can also create custom operations as well. So if you are doing a custom operation, we can simulate those. So I'm going to add 4 operations. I'm going to add first, I'm going to do a single action draw. Then I'm going to do a trim operation. Then I'm going to do a flanging operation. And then I'm going to simulate the springback. So those are the 4 operations that I'm going to set up. We can reorder these, like if you've clicked them and you want to reorder them, you just sort of drag them around. But obviously this is the order that they'll obviously simulate. So we do a single action, then into a trim, then to a flange, then the springback final. When you click on the springback, obviously now we can start to assign the tools. So here we've got, just normally we add a top die, bottom binder by default, but if you're using cam pads and things, you can add those as well. So you can add any tools and you can remove any of these as well. You know, you just right click on them and remove them from the list here, and you can create your own setup. So these are all the different types of tools that we can use. So we're going to set up the tools first of all for the single action. You can notice we've got a draw direction now as well. That's obviously correct in my instance, but if you need to change that, you just need to double click on it and you can change your draw direction. One nice thing about the software was the ability to actually auto configure the tool. So I've literally got a blank and a top die. I can use that to actually auto configure the tools. So I'm going to click this auto configure. I'm going to go through the other ones manually, but just show you this auto configure because it's quite nice. I'm going to tick the option to build tools, and then I'm going to click here, auto configure, and hopefully I'll end up with a top die, a bottom die, and a bottom binder. So you can see now sort of this color grade, and in here, the left-hand side, if I just isolate that, we've got my top die, we've got my bottom die, we've got a bottom binder, and obviously we've got the blank. So so it's very quickly created all those tools. If you want to go in and modify them, we can click on the top die and we can modify the distances and the friction coefficients. Same thing for the bottom die, and the bottom binder, obviously the force. You can again modify that to suit. So you can just change the force there. So once the tools have been created, you can modify them. You can also simulate or just preview the motion. So we can sort of simulate the motion that's going to take. So that gives you a bit of a preview. But now we can move on to the next operation. So I'm going to move on to the trim operation here. We've already got some lines that are obviously going to be the trim lines. So if I click on the trim tool, the first one, I'm going to manually click on this one, and that's going to be my trim line. I'm going to also specify a pierce line for this other curve here. So those are both my trimming operations that's set up. Then I can go into the flanging operation. So for the flanging operation, I am going to, sorry about all that beeping. So I'm going to import another part. So I'm going to click on File, Import, and actually going to bring in my flange tool. So that's imported in. Again, with this, you've got your different tools. So we can obviously have any tools we wish. I'm going to specify this as my bottom die, and I'm going to make sure I'm offsetting it, hitting the Create tool. And what that will do is just offset it, but it will create a copy of it. So it's just offset it, and again, we can specify the distance. So I'm going to keep the friction coefficient as the default. Now I can specify my top die, and I'm going to say assign. And again, I'm going to keep the rest as default. So I'm going to click apply. And then finally, I'm going to choose my top pad. So in this instance, I'm actually going to specify surfaces, and I'm going to choose these 3 surfaces as my top pad, and I'm actually going to partition them. So once I create those, you'll see again what happens. So those have been partitioned, and again, we can apply the forces for this top pad. So if you want to simulate that or preview that motion, again, we can preview that motion. Finally, last thing to do is the springback. I can just obviously configure I'm going to auto configure this, but we can add reference tools and constraints for your springback as well. When you're ready to run this, same within the feasibility tab, we've got the option to specify our mesh size, animation frames. So it's quite a nice workflow in terms of analysing. You can choose your mesh size, very easy, medium, fine, coarse, or a custom mesh size, and then you can specify your layers and things. So then you can click the run tool. Again, rather than running this, because we have got 4 operations now that we'll be simulating, I'll just open up a pre one that we did earlier, sort of Blue Peter style, and this will show you the results that we can get in this stage. So this is the results. Let's load the results in. So we're looking at the first stage at the moment. Let's simulate that back to from the start. You can modify the transparency of your tools. I like to keep them pretty much transparent so you can see the actual flat blank and the operations. Again, your animations here, I'm going to slow this right down so you can see it clearly. And I'm going to run it sequentially. So I'm going to go through all the operations sequentially. And then we're going to hit the play button just so you can see sort of what's happening. So we've got a single draw, then straight into the trimming. Then we've got our flanging operation. And then we are springback on finally our springback analysis. So those were all the operations that we've obviously simulated, all those 4 stages. If we look again to our analysis explorer, we can go into these in a little bit more detail, so we can start to look at the all the stages. So this is obviously our drawing stage. So we're going from that flat blank to the part, and we can start to look at our results again. We can start to look at things like formability. So we can see we are actually getting some failure in this area here. So that could lead to obviously saying that we're actually going to see some splits. So that might be something you want to work on, maybe change the size of a rad, maybe change the material, little things like that. Obviously the process, iterating the process parameters we can start to look into. But we can see the formability, so then we can look at different operations, and then we can look at the flanging operation. Finally, we can look at the springback, and let's just have a look at the springback. If I look at it from this angle, we can start to see that springback, and then again, these are all the options that we can see. I'm aware we haven't got loads of time, guys, so I'm sort of flying through this. But if you've got questions, please feel free to ask them. So different types of analysis that we can see in these stages are obviously the same things: our thinning, thickness, thinning delta, and formability, our failure, the different strain and stresses. But we can also look for things like surface quality and things as well. Obviously, for springback, you might be interested in the deformation, so we can start to see our deformation of the part, and we can look at the values and again put call outs on these. So we're seeing a 2 mil deformation in this area. Finally, last things to touch on, again, I can't show you everything in the software trying to, but we do have these two options to redesign the part. So what this tool allows you to do is actually compensate for springback. So this will actually readjust the actual die itself, and basically you pick fixture points on the model, and this and then it's an iterative process, but then it readjusts the die face, and then you can see if your springback actually decreases. Once you click apply, a new die tool will be created, and then you can start to optimize your design based on that. So you can see I've gone from 2 mil displacement to a 1.1 just by applying, and this is what the new tool will do. Another thing that we can do is actually predict the blank shape. So if you're using a blank that maybe has got excess material or it's not got enough material, you can use this tool to actually predict the blank shape. I'll just very quickly, 30 seconds, show you an example of this. So once it loads. Okay, so this is we've run a simulation, just a single action, and then we've used this tool to actually predict the blank shape. So this is the predicted blank shape, and this is the original blank shape. So we can see that's the original blank shape, and then based on the simulation, they've said, you know, you could this is the where have I lost it? This is the predicted one. So you can see obviously slightly smaller. Obviously, you might not use that exact shape because obviously you can see it's a little bit rough. It's an STL, but then you could use that, take that back into your CAD system, refine it, and potentially use those that predicted blank as well. So again, that's an iterative process. Again, if you've got questions on those redesigns, please feel free to get in touch. I'm aware I don't want to go over the sort of 3 o'clock sort of time because I don't want to keep you too long. But I'm going to end the demo now. And if you have got questions, hopefully we can answer some of them now. If we can't answer any of them, we'll definitely get back in touch with you. But I'll go back to sharing my screen, and then Rob can probably finish this off.
Yeah, thanks, Tim. I mean, we've only got a couple of minutes. I think Corinne will shortly put a poll on screen. Hopefully, you've enjoyed the demonstration. You know, we're very happy to spend more time with you. You know, whether you've already got simulation or perhaps you're trying to introduce it for the first time. So, you know, helping out with a demonstration, perhaps using one of your parts, very happy to do. If you're comfortable with the simulation technology already and perhaps you want to benchmark it against what you're already using, perhaps we can do that as well. So very happy to make trials available, and of course share you know, numbers with you if required, or provide additional information. So I think that we've got a couple of minutes. So if anyone does have questions and haven't already asked them, now's your time to get them in. I think once everyone's voted, Corinne will close the poll, and then Tim will put our details back on the slide. But Corinne, I'm not sure whether you can multitask, but I don't know if whether we've got any questions in already, perhaps while people fill out the poll?
Yes, so there are a couple questions. So the first one that popped during the demo is asking, can we customize the tools like the die radius?
So yes, the actual tools. So when you say customize the tools, I presume the tools have come in from obviously your CAD tool. So when you say customize the tools, we can redesign them, which hopefully you saw there with that little last bit with the springback, which will basically redesign the actual die itself. But obviously you can customize them in terms of like radiuses and things using the geometry tools within Inspire. But then also you might be more familiar using your CAD tool to actually physically change the die. I'm not sure I've answered the question there, but if I've misunderstood, feel free to drop us an email.
Thank you. There is another question. Is this just for dry forming, or can it take into account different forming lubricants?
Oh, I think it is just dry forming. Yes. Good question. I believe it's just dry forming, but again, I will confirm that, but 90% sure it's just dry forming.
Okay, another question is, have you validated the wrinkling prediction in deep drawing?
Yeah, Altair. This software has been around for quite a long time. So Altair have been working on this software, I think, since like the 90s. This is where this software has evolved from. So I presume they've done all the validation studies. I would imagine so. I definitely think they will have. So the answer is yes.
Okay, another question is, does the solver run any mesh refinement algorithm?
So it's got what we call like it's auto meshing. So it's using Altair's like HyperWorks sort of solvers in the background to actually mesh the parts. In terms of refinement, you can control the mesh yourself. Like you can choose the actual mesh size. What the software does automatically is it looks for like high areas of curvature and it'll apply more mesh elements to those areas. Obviously, flat planar, no features on, it'll apply less mesh elements. But you can obviously control your mesh exactly if you want every single mesh element to be 1 mil. You've got control over that. But the auto meshing will basically look at the actual features of the model, and then that's how it controls it.
Okay, there's another question. Can we simulate SPF and hydroforming?
SPF and hydroform, I don't think so. Again, I will confirm and get back to you, but I don't think we can, unfortunately.
Okay, and I think a question is kind of a follow-up from earlier about forming lubricants. Is there a library of lubricants in the software?
Again, I don't think so, but again, I will double check just in case I am incorrect there, and we will get back to you. But obviously, that might be a similar answer to the one previously.
Another one is about the thickness. Can we simulate thick sheets like 10 millimeters?
I don't think there's any limitation on thickness. You just again, it's just going to be scaling up. Obviously, I was just using 1 mil there, but you can put in any thickness of your choice.
Okay, one more question, I think. Basically, why? Well, sorry, I lost it. Why should we use Inspire Form over other forming software?
Do you want to answer, Rob? Or
yeah, well, I mean, yeah, I think it always depends what you use. You know, there's pros and cons of any piece of software, and you know, no doubt we'll have some features that other products don't, and they'll have some features that we don't. I think when we I think our main selling points, if you like, you know, is the ease of use. I mean, Tim's just sort of done that all live. I mean, admittedly, he's loaded in results, but he was playing around and setting up the simulations all live. And I hope you'll agree, is relatively easy to follow, and it doesn't require much training. Because it doesn't require much training, you know, I think different people with different skills can use it. So, you know, you can use it very early on in your design, or, you know, for those that are doing the manufacturing themselves, they can do more detailed design. So I think it's sort of one simulation tool that can be rolled out to different skill sets. as Tim said, because it is a cloud-based license, you know, you're not paying per seat, so you're not restricted to the amount of people that you can give this tool to, and it's also, you know, pretty affordable in terms of cost as well. So, you know, if anyone needs reviewing something or has something and they do want to look at the differences, you know, we're happy to get into a more detailed session and perhaps get you a trial so you can sort of evaluate the differences yourself. But yeah, hopefully that answers your question to some extent, but I guess it depends on what you're currently using in order to compare it.
Perfect. So I think we went through the questions. If we missed any, you know, Rob and Tim will follow up with you. I see we got a couple of people requested trials and demonstrations. So again, you know, the team will follow up with you and set that up basically. But I think based on the time, we might need to close the session now, Rob. If you want to, yeah, you've got your details on the screen. Yeah,
yeah, I've got our details, and yeah, just you know, a thank you from all of us for attending. I hope you enjoyed it.
Thank you very much.
Thank you from me.
Thank you for presenting, and thank you everybody for attending. Have a good rest of the day. Okay. Bye.
Bye. Thanks.